Hello dear students, in this video we are going to start new chapter Determinant. Myself Professor Vaishali Bharat Ghulab. See, a determinant of a matrix represent a single number. Okay, with the help of determinant we can represent the matrix in a single number. We obtain this value by multiplying and adding its elements in a special way that we are going to see in next slide. Determinant of matrix of order 1. Order 1 means one row and one column. Okay, determinant of a matrix of order 1, that is A is equal to, this is matrix A11 means first row, first column, order is 1 by 1 is, always we write the determinant in two vertical bar, capital A is equal to, determinant will be the value of that matrix, that is A11. Then determinant of order 2. Order 2 means there are two number of columns and two number of rows. Determinant of matrix A, A11, A12, A21, A22 is simply we write down the two vertical bars. Between two vertical bar we write down all the elements of matrix, that will be, we call it as a determinant. Okay. Here how we can expand or find out the value, that is by multiplying and adding in a special way. This is the special way through which we can find out one single value for these four values. Okay. Here A11 into A22 minus A12 into A21. This is the expansion of the determinant of order 2 by 2. Now determinant of order 3. A determinant of order 3 is a square arrangement. You can see here square arrangement of 9 quantities. Square arrangement of 9 quantities, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. Enclosed between two vertical bars, and arranged in 3 rows. Horizontal lines we always call as row and vertical lines we call it as a column. A determinant of order 3 is a square arrangement of 9 quantities, that is A1, B1, C1, A2, B2, C2, A3, B3, C3 enclosed between two vertical bars, arranged in 3 rows and 3 columns. That we call it as a determinant of order 3. Now how we can find out the value of that determinant? Here I have expanded this determinant along first row. Expansion of determinant along first row. Listen carefully. A1, B1, C1 is the first row. I have find out the value of determinant by expanding the given determinant along first row. Okay. Now first element of first row A1. Now we write down the determinant by eliminating this row and this column. What are the remaining elements? B2, C2, B3, C3. B2, C2, B3, C3 minus second element of first row, that is B1. Now we again write down the determinant by eliminating this row and this column. Then what is the resulting determinant? A2, C2, A3, C3. A2, C3, A2, C2, A3, C3 plus third element of first row into remaining elements of that determinant, that is we are eliminating this column and this row. What is the remaining elements of this determinant? A2, B2, A3, B3. Okay, A2, B2, A3, B3. Now expansion, in previous slide we have seen the expansion of 2 by 2 determinant. A1 in bracket B2 into C3 minus B3 into C2 minus B1 A2 into C3 minus A3 into C2 plus C1 A2 into B3 minus A3 into B2. This is the expansion of the determinant of order 3 by 3, means 3 number of rows and 3 number of column. Now evaluate the determinant 1 to 4. 2. This is the determinant of order 2 by 2, means 2 number of rows and 2 number of column. See how we can expand. 1 into 2 minus 2 into 4. 1 into 2, 2 minus 4 into 2 is 8. 2 minus 8 is minus 6. This is the value of determinant of 1, 2, 4, 2. Now evaluate the determinant. This is a determinant of order 3 by 3, means 3 number of rows and 3 number of column. You can see here. Here I have expanded the determinant along first row. 3 minus 4, 5. Now first element of first row 3 into remaining elements. Now we are eliminating first column and first row. Remaining elements are 1 minus 2, 3, 1 minus second element of first row minus 4. Now eliminate this column, this row. Resulting determinant is 1 minus 2, 2, 1 plus third element of determinant first row is 5. Now remaining elements are the determinant, that is eliminate this column, this row, remaining elements 1, 1, 2, 3, 1, 1, 2, 3. Now expansion of second order determinant. 3, 1 into 1 plus, why here plus? 1 into 1 minus minus 6, that will be plus 6. Plus minus minus plus 4. 1 into 1 minus minus 4, that is 1 plus 4 plus 5. 1 into 3 minus 2 into 1, that is 3 minus 2. Now simplifying this, 3 into 7 plus 4 into 5 plus 5 into 1. 21 plus 20 plus 5 will give 46 is the determinant value of the determinant of order 3 by 3. Now properties of determinant. Okay, there are only statement in your syllabus, no proof. That's why we are going to see only statement with example. If rows and columns of a determinant are interchanged, then the value of determinant remain unchanged. If we are interchanging rows into column, means we are finding the transpose. Remember, we have seen in the matrices chapter. Okay, if rows and column of a determinant are interchanged, then the value of determinant remain unchanged. Okay, or remain same. See, you can see A1, B1, C1, A2, B2, C2, A3, B3, C3. This is the determinant when we interchange rows into column. You can see here, this A1, B1, C1 is first row, here will be first column. A2, B2, C2 is the second row, will be second column. A2, B2, C2. Third row will be third column. Then the value of determinant is same or unchanged. Second property, if any two rows of a determinant are interchanged, then the value of determinant change by sign only. If any two rows or columns. Here you can see in example A1, B1, C1, A2, B2, C2, A3, B3, C3. I have interchanged the first row with second row. You can see here first row, here will be the second row, and second row will be first row. Then the value of determinant is changed by sign only. If any two rows or column of a determinant are identical, the value of determinant is 0. You can see here A1, B1, C1. Second row is also A1, B1, C1. A3, B3, C3. Then we can say that then the resulting value of that determinant is 0. If any two rows or columns of a determinant are identical, then the value of determinant is 0. Fourth property, if each element of row or column of a determinant is multiplied by a constant k, then its value get multiplied by the same constant k. You can see here k is a constant, ka1, kb1, kc1. A2, B2, C2, A3, B3, C3. That will be, we can write K as a constant outside the determinant and remaining determinant value, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. That is, if each element of row or column of a determinant is multiplied by a constant K, then its value gets multiplied by the same constant K. Last property, if each element of row or column is expressed as the sum of two numbers, then the determinant can be expressed as the sum of two determinants. See, first row is represented as a addition of two numbers. Okay, sum of, then resulting determinant will be addition of two determinant. A1 x1, B1 y1, C1 z1, A2 B2 C2, A3 B3 C3. Then resulting determinant will be A1 B1 C1, A2 B2 C2, A3 B3 C3 plus X1 Y1 Z1, A2 B2 C2, A3 B3 C3. These are the properties of determinant. Thank you.